Hey there, this is Hollis from group 23. I'm going to show you some of our testing. First method I'm going to show you is the calculate row total. As you can see, it's applied a data table that implements the values 2D interface. We don't want our test to rely on this class, so we implemented a mock. I'll show you how that works. So if we hop over into the code, using the before annotation, we set up our mocks for each test case. So our mock in context, and then our mock object that's going to be used to simulate the values 2D, the object that implements the values 2D interface. So then if we jump down to our code, this is the calculated row total. We use descriptive names to show that we're testing for all columns with row 0, and the data type in the table are positive doubles. This would be an example of a boundary test case because we're testing the first row of our array or of our values 2D. This is the mocking context where we set up the expected return values from our mock. So if the values 2D is expected to get the get column count method, we're going to declare that it gets returned a value of 3. And then for each of the get value calls for the row 0, so for column 0, 1, and 2, we specify the return value. Down below, we have a result where we call that method, which is going to use these mocks that we defined above. And then we assert with the descriptive message, the expected value of 6, summing 1, 2, and 3, and the actual result that we calculated from the function call above with a specified tolerance. So I go and run this code here. We can see that it passes. And now similarly, we're going to calculate the row total for all columns, but using a nominal row value 1, which is in the middle of the values 2D, which is of length 3. So we select the first row so that it's a nominal value in the middle. The same mocking values are set up here with the different row specified in the first index. We return the result that's going to call the methods specified in our mock. We assert that the result is 6.0, given that it sums 1, 2, and 3. If I run this test case, we see that it passes. So now we're going to show calculating the row total where we specify which columns we want. So in this function, we're going to simulate with our mock getting the values from row 1, column 0, and row 1, column 2, as specified in the name. And when we make the call to our function, we specify the columns that we want, being 0 and 2. If we run this function, we see that it passes. So now we're going to show the calculate row columns where we specify the columns, but one of the columns we specify is going to be out of bounds. We have our mock set up here to have 3 columns, but when we actually query it, we're going to query column -1, which is out of bounds. In the actual function call, we specify the columns to be -1. In the values 2D specification, it says that if a row or column is queried that's out of bounds, it'll raise an index out of bounds exception. So we define that behavior here, and we actually catch that exception to allow it to pass. If the exception isn't thrown, then the test will fail. So if we run this, the test passes. Just a quick note about some of the challenges we faced during the testing. A lot of the specifications for methods like this get cumulative percentages aren't very descriptive. So the spec says that the percentages are supposed to be values between 0 and 1, but when you give it negative values or when the cumulative sum dips below 0, some of these percentages don't fall within the 0 to 1 range. It's not defined how to handle this, so this is one of the challenges we faced. So I'm now going to walk you through one of the range class methods called expand that we tested. This method takes in a range and then a lower and upper margin, which are both doubles. We hop over into the code to one of the tests. The range class, the range object is defined up here above, starting at 0, ending at 1. And then if we hop down to the test, we're given a lower margin and upper margin, both of 0.5. So we expect the lower margin, the lower end of the range to be -0.5 after this expansion, and the upper band to be extended by 0.5 as well to 1.5. If we run this test, We see that it passes. And now to test the expansion with negative values, we're given a lower and upper margin of negative 0.5, and we expect now that this range will contract from 0 to 1 into 0.5 to 0.5. And if we run this test, we're testing the assertions down here at the bottom that it does contract to exactly that, and on the left here, the test does pass.
Hello, this is Mo, group 23, and I'm here to show some of the test cases we developed here, especially for from the range class. We're here testing a bunch of methods. I'm here gonna show the expand to include test case number one, which is here testing with the value greater than the upper bound of the range. The initial range is between 0 and 1, as you can see, and I'm gonna run this test case, which is testing with a value greater than the upper bound, and this is passed, as you can see, for this test case. And now I'm gonna try to another test case for this method, expand to include, with a value lower than the lower bound, less than the lower bound, which is -1. Run and pass. And I'm gonna now try another method, which is inside the data utilities. This method is the expected behavior not accepting any value or that out of the bound. So we are testing here with a value -1, which is should be throw an error index out of the bound. So this test is checking the behavior of this method if the index of the column is -1, which is invalid index because it's out of the bound. And the test case of here using the mock the JMock to mock the behavior of the values to these method, as you can see here. And as the test goes, is first we are checking getting the rows count, which is gonna give us is gonna return 3, and then we're gonna get the value, and then get the value method of the values to 3 object, which was called once, and the argument with between 0 and -1, I should throw an index out of the bound message, and that should be catched by the test. And then we're gonna, when we call calculate the total method and check if it's out of the bound, and should throw out of the bound error. And here gonna run it, and it passes, it throw a message out of the bound error. Thank you.
Hey, I'm Ken. I'll be showing you the shift method within the range class. So here it is. It shifts the range by the specified amount and returns a new range. So if we head over to Eclipse, we have here our shift test 1, which has a delta of 0.5, allow crossing true, and here we shift our results from our lower bound of 0 and our upper bound of 1. So we should see a shift to 0.5 and 1.5. So now, if we head over to run that test, we can see that it passes. So now I'll be showing you in the data utilities, the get cumulative percentage method. It takes the key values and returns those key values cumulative percentages where the percentages are 0 and 1. So heading over to Eclipse, we have our cumulative percentages with 3 values of positive integers. So if we look here, we have the key value pairs of 0 for the key, 2 for the value, 1 and 1, and then 2 and 2. So what we expect to get here is 0.4, 0.6, 0.1 back. Let's run that test now. Running the JUnit test, we can see that it passes.
Hi there, my name's Steve Thistle from Group 23, and I'm going to run down through another data utilities class method. Here, calculate column total. We've designed a test class called test calculate column total with valid rows, rows 2, column 0, positive doubles. And as you can see here, we're basically going to call column 0 with row 2, and we expect a result of 3. So up above here, we basically set up our mocking context here. We have our mocked up 2D array, which we've initialized earlier. We can see here that the basically this row here, this line of code, says the expectation is set that the get row count method will be called once on the values 2D object and will return a result of 3. And then this next line, get value, takes arguments of 2 and 0, the row and column values, and this method will be called once on the values 2D object as well, returning a result of 3. Below here you can see that we call the data utilities method with the arguments I mentioned previously, the mock object, column 0, and row 2. And here is our equals assertion, rather assert equals, and we expect this to pass with a result of 3. If I run it, we can see here that it runs successfully. Okay, next I'm going to show you guys a range class method test named scale test 4. We're going to add some comments to the code above these tests post video, so you guys will have a little bit more description, but certainly I'd like to draw your attention to the Excel table, or the markdown tables rather, in our markdown file. So this particular test is, we're going to test the range.scale method, which takes a range object and a factor. This factor should be non-negative, so we're testing basically a negative number here to ensure that it actually behaves as expected and throws an error. So you can see here we've included a fail statement in the event that it didn't fail, but you'll see here in a moment that this particular, it will throw an error, it will get caught, and this is assert equals will pass. So let me just run it here, and you can see it does pass. So it is actually not working with the -1 as expected. Okay, I'm now going to cover scale test number 7, again testing the range method scale, which takes a range object and a factor. In this case, we're going to try to test sort of an edge case, or a bit of a peculiar case here. We know the factor should be positive, non-negative. We're actually going to try to utilize a double.nan, not a number, an undefined parameter, if you will. And initially we expected this to fail, but the range.scale method actually handles this and results in a range of nan, nan, lower bound nan, upper bound nan. So it's sort of an impractical result, but it doesn't fail, and so we've defined it as undefined in our results table in our markdown report. I'll just run it here. You can see it run, and it actually passes.